Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of extended product rule. So as per the problem, use the extended product rule to differentiate the following functions. So let's start with the function on the left side. So the given function is y equals x plus 1 to the power 3 times x plus 4 times x minus 3 squared. So as you can see, this function is a product of three functions. So the first function is x plus 1 cubed, the second one is x plus 4, and the third one is x minus 3 squared. Now for this function, we cannot use our regular product rule because that product rule is only useful for a function that's multiple of two functions. But in this case, this function is made up of three functions that are being multiplied. So that's why we have to use the extended product rule. So as per the extended product rule, so we have to find the derivative of one function and then keep the other two the same, and then plus the derivative of the second function, and we keep the first and the third one the same, plus the derivative of the third function, and we keep the first and the second functions the same. So let's get started. So our first step is, so y prime, so I'm using the prime notation, equals, so the derivative of the first function, and as per the power rule, it will be 3 parentheses x plus 1 exponent 3 minus 1 times the derivative of the inner function x plus 1, which will be 1 plus 0, times the second function, then times the third function, plus, now we'll keep the first function the same, x plus 1 cube, and now we'll find the derivative of the second function. So that will be 1 plus 0. And the third function we'll write as it is. And then plus, now we'll write the first and the second functions as they are, x plus 1 cube times x plus 4 times the derivative of the third function. So as per the power rule, so it will be 2 and then x minus 3 exponent 2 minus 1 times the derivative of the inner function, which will be 1 minus 0. Now we can simplify this expression. So we get y prime equals 3 parentheses x plus 1 exponent 2. Now 1 plus 0 is equal to 1, and multiplication by 1 won't change anything, so we can ignore that. Now we'll just write the other functions, x plus 4 and x minus 3 squared. And now we can simplify the second part. So it will be x plus 1 cube. Now 1 plus 0 is just 1, and multiplication by 1 won't change anything. So that parentheses goes away, times x minus 3 squared. Now we can simplify the third part, plus, now we can move this 2 to the front. So we get 2 and then x plus 1 cube times x plus 4 times x minus 3. Now the exponent of x minus 3 is just 1, and we don't write 1 as the exponent, and then 1 minus 0 is equal to 1, and multiplication by 1 doesn't change anything. So this can be the final answer for the derivative of the first function using the extended product rule. So now we can analyze the second function. So I can use a different color. So the second function is also made up of three different functions being multiplied. So the first function is x squared, the second function is 3x squared plus 4 squared, and the third function is 3 minus x cubed to the power 4. So let's start by using the extended product rule. So y prime equals, so the derivative of the first function, that will be 2x times the second function times the third function plus, now we'll keep the first function the same, times the derivative of the second function. So we'll use the power rule, so 2 and then 3x squared plus 4 and then exponent 2 minus 1 and then times the derivative of the inner function, so 3x squared plus 4, which will be 6x plus 0 and then times the third function, so 3 minus x cubed exponent 4. Now plus, so the first function and the second function will stay the same. Now times the derivative of the third function, and that will be 4. So we are using the power rule, times 3 minus x cubed exponent 4 minus 1. Now times the derivative of the inner function, so it will be 0 minus 3x squared. Now we have to simplify this expression. So y prime equals, so the first part will stay the same, there is nothing we can simplify. So 3x squared plus 4 squared and then 3 minus x cubed exponent 4. Now in the second part, we can simplify 2 times x squared, so we can move this 2 to the front. So it will be 2x squared and then 3x squared plus 4 exponent 1, but we don't have to write that. Now 6x plus 0 will just be 6x and then 3 minus x cubed exponent 4 plus, now in the third part we can multiply 4 and x squared, so we get 4x squared and then 3x squared plus 4 squared and then 3 minus x cubed exponent 3 and then 0 minus 3x squared is negative 3x squared. So now in the next step we can simplify the second and the third part. So the first part will stay the same, so 2x and then 3x squared plus 4 squared times 3 minus x cubed exponent 4 plus, now we can multiply this 2x squared by 6x. So we get 12x cubed times 3x squared plus 4 and then 3 minus x cubed exponent 4 plus, now here the sign of the third term will change because we'll have to multiply 4x squared by negative 3x squared. So we'll get negative 12x exponent 4. So then it will be 3x squared plus 4 squared and then 3 minus x cubed exponent 3. So this can be the final answer for the derivative of the second function. Now if we want, we can factor it further, but this can also be the final answer. So these are the steps we have to keep in mind to solve a problem like this one. If your teacher expects you to simplify these expressions further, what we got as the final answer for the first and the second function, then you can do common factoring and factor out the common terms from each part and write the answer in more simplified form if it is required. Otherwise, these can be the final answers for the derivative of these functions. So I hope you'll find this video useful. So you have to be careful about using the extended product rule, which is used for functions in which three functions are being multiplied by each other. So if you find the video useful, please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.